Hello, welcome to my channel Aperture Physics, a complete class note series. In this video, I will discuss about some numerical problems which already come in the board examinations. And at the end of this video, in the description box, you get the link to download this class note also. And obviously, you also get the link for the next video. If you subscribe this channel, you will be automatically notified when any video will be uploaded in this channel. Let us proceed now. Problems based on board exam topic Gauss's theorem. In the first question, a cube with each side A is kept in an electric field given by E vector is equal to C x I cap. That means the value of the E depends upon the x positions and the direction that is along the x-axis, and it is given in the figure diagram where C is a positive dimensionless constant. Now task is find out the electric flux. Find out the electric flux through the cube and the net charge inside the cube. And the net charge inside the cube. Now look at the figure carefully. Here it is one cube. Each side A, and it is the origin. The first surface number 1, that is at a distance A from the origin, and the second surface, that is the 2A from the origin, and third surface that is perpendicular to the y. Fourth surface also perpendicular to the y-axis. First and second surface are perpendicular to the x-axis. The electric field, it is x dependent. Therefore, the electric field at origin it is a 0, but here it has more value, and at the second surface the value will be more, but there will be no component along the y-axis, along the x-axis. Now our task is to find out the total flux associated to this Gaussian surface or to this cubic surface. In 3D closed surface, ds, that means area vector, is always taken outwards and normal to the surface, and it already we have discussed it. In this chapter, the area vector, that is the positive direction of the area vector, that is already taken perpendicular to the surface and outwards for a closed surface. Now net flux through the cube is the sum of the all fluxes passes through each 6 surfaces. There are 6 surfaces, and when we want to find out the total flux, then we have to calculate the flux through each surface and we have to then add it. That means mathematically we can write phi net is equal to phi 1 plus phi 2 plus phi 3 plus phi 4 plus phi 5 plus phi 6. That means these are the electric fluxes through the first, second, third, fourth, fifth, and sixth surfaces. And mathematically you can write that E1 dot ds second sub plus integration E2 dot ds plus in this way you can write it. Here we are using E1, E2, E3, E4 because the electric field is not uniform. There is distance dependent from the origin. Now here for the first surface and second surface, for the first surface the value here a ds vector, area vector, that is perpendicular outwards, but the electric field it is from the left to right, and the angle between these area vector and the E1 vector, that is 180 degree. But here the area vector and E2 electric field at that point both are in the same direction, and therefore angle between the two vectors 0 degree. But here it is the 180 degree. But in all other surfaces, the electric field and the area vectors, these will be perpendicular to each other. Here we are observing the two surface, and that is surface 3. In this case, at any point the electric field, and that will be different at the different point, but always that electric field that will be perpendicular to this area vector anywhere. That means the theta is the 90 degree. Therefore, there will be no flux because cos of 90 degree will be 0. Similarly, in the fourth surface, theta is also 90 degree. And another the two surfaces, there also the theta will be 90 degree. Then electric flux that will be only due to the first and second surface. Here cos of 180 degree, that is minus 1, and 0 degree, that is the 1, and all other surfaces the flux 0, because there is no field lines passing through these surfaces. Now total electric flux for the first surface, it is now become negative. And another way you can think it, all the incoming flux that are the negative, here automatically mathematically it is negative because the theta is the 180 degree, and here it is the positive. Now that is what is the value of the E1 and E2. E1, it is given that E vector is equal to Cx into I cap, where for the first surface x, the value of the x is a, and the second surface value of the x is 2a. By putting in the value of x for the two surfaces, that means by putting the value of E1 and E2, we get this type of calculations, minus C A cube plus 2C A cube, that is a C A cube. Therefore, the flux is, it is in SI system. If you write in SI system, the unit will be Newton meter square per coulomb. Net flux will be C into A cube. And from the Gaussian theorem, we know that net flux is equal to Q net divided by epsilon naught when the charge is placed in vacuum. Here we considering the charge is placed in free space, that we are taking the epsilon naught. Then what will be the net charge? The epsilon naught into, what will be the net charge? Epsilon naught into now answer is net electric flux, that is a CAQ, Newton meter square per coulomb. Another net charge is, that is the epsilon naught into C into AQ. Now our next question. Two parallel uniform charge infinite plane sheets 1 and 2 have charge densities plus sigma and minus 2 sigma respectively. Give the magnitude and direction of the net electric field at a point number 1 in between two sheets and number 2 outside near the sheets. Now for the first question, number 1, number 2, there are two parallel sheets of charge. In number 1, the charge density is plus sigma, and second, that is a minus 2 sigma. Due to the plus charge, the electric field will be away from this, and for the negative charge toward this, electric field intensity E1 sigma divided by 2 epsilon naught minus j cap. We are taking horizontal axis direction, that is the x, and there is a y, that means j. Therefore we are using this, we are considering it. It is not given in the question, but you can consider it for the easiness. Now E1 and E2, between the two plates, the electric field both are in the same direction from positive to negative. Their values are different because the charge densities are different. So E1 vector, that is the sigma divided by 2 epsilon naught minus j cap, and E2 also 2 sigma by 2 epsilon naught. Therefore total electric field, that is the vector sum of two electric fields, E1 vector and E2 electric field vectors. And from that we can write here this one, and after the calculation you will get minus 3 sigma divided by 2 epsilon naught j cap directed towards sheet 2, that is positive sheet to negative sheet. Now the second part, for the second part, outside near the sheet 1, what will be the electric field outside near the sheet 1? Near the sheet 1 outside, the electric field due to the sheet 1, that is away from this, in this figure it is upward, and due to the negative, that is toward this. Since the electric field is independent of the distance, therefore value will remain unchanged here and here, anywhere. And here the electric field E1 and E2, these two are in opposite directions. E1, that is along the positive j axis, y axis, that means j vector, that is sigma by 2 epsilon naught, and E2, that is the 2 sigma divided by 2 epsilon naught minus j cap. Therefore what will be the resultant? That is the vector sum, E1 vector plus E2 vector. sigma divided by 2 epsilon naught j cap plus 2 sigma divided by 2 epsilon naught minus j cap, and ultimately minus this one. Or you can say E vector here outside of the two plates and the side of the first plate. It is the one plate and it is the second plate. That is sigma divided by 2 epsilon naught minus j cap directed towards it 2. That means ultimately the direction will be along this final direction, resultant directions. Now another question, question number 3. A right circular cylinder of length A and radius R has its center at the origin and its axis along the x-axis, so that one face is at plus a by 2 and the other at minus a by 2 as shown in the figure. A uniform electric field is acting parallel to the x-axis such that E vector is equal to E naught I cap for x greater than 0 and E vector minus E naught I cap for x less than 0. That means, look at this figure diagram. It is the given cylinder whose radius is r. It is one plane surface, it is another plane surface, and it is given that the length of this is a center, that is the origin, axis of the cylinder, that is x-axis, obviously it is perpendicular, that is the y-axis, and electric field when x less than 0, that means along the negative x-axis directions, the electric field is given here minus E naught I. Since there is no x term here, therefore it is independent of the x. That means value will be remain unchanged, but directions, that is at the left hand side, always from left to the right to left, that is along the minus I cap or x-axis, and it is given here when x greater than 0, that means at this side of the origin, right side of the origin, x E always positive, and that is the E naught. Now what will be the question? What is the questions? Find the flux through the flat surfaces. There are two flat faces. We have to find out the flux through the flat faces, and number 2, the curved faces. What is the net amount of flux through the cylinder and what is the net charge inside the cylinder? Here there are 3 surfaces. When we consider the 2 flat surfaces, here E vector and ds vector both are along the same directions. Here also the ds vector, that is perpendicular to the surface and outwards, and here also the E vector, that is -1, that is also outwards. These two are along the same directions. So when we here get the flux is outwards, here also flux is outwards. The flux through the flat surface, both first and second, with the first and second both surfaces, phi 1 is equal to surface 1 E1 dot ds plus surface 2 E2 dot ds, and that is this E2 this one, and ultimately it is the same direction, therefore E naught ds, and here also E naught ds, and 2 E naught ds, integration ds, that is pi r square, integration of the surface, that the pi r square, it is a circular surface, therefore total flux will be 2 pi epsilon naught into x square, that is the total flux. Now flux to the curved surface, total flux, not total flux, it is flux passing through the 2 flat surfaces. Now flux to the curved surface, anywhere, any point on the curved surface, the electric field and the area vector, ds vector, these two are perpendicular to each other. Therefore when we take the dot product, the cos of 90 degree, that will be 0, and there will be no flux passing through this curved surface, and we can guess it since electric field parallel to the x-axis, therefore there will be no component along the y-axis, therefore there will be no electric flux through the y-axis. Mathematically also we can find out there is no flux passing through the curved surface of the cylinder. So total netward flux through the cylinder, that will be phi 1 plus phi 2, and it is this total flux. According to Gauss's theorem, phi net is the q divided by epsilon naught. According to Gauss's theorem, net flux is equal to q divided by epsilon naught. That means charge inside the cylinder, q is equal to 2 pi epsilon naught r square into E naught. Now it is end of this questions, and for this class note, you get the link in the description box. You may download it, and you can subscribe the channel to get the notification of any new uploaded video. Now it is